Hi, everyone. Welcome to another SQL Maestros webinar. Today, we are going to talk about SQL Server internals. And this is what the title is, SQL Server internals you may not know. What I've done in this webinar is I've picked up 5 internals and I've kind of spread it across different aspects of SQL Server, like something to do with the architecture, something to do with memory, something to do with CPU, one of the internals is about the internal locking and transactional behavior, then statistics and indexes. The idea of spreading the internals knowledge across different aspects was that so that it addresses many SQL Server roles. You might be a developer, a DBA practitioner, or you're just working as a reliability engineer in support. Any role, there will be something for you. That's the idea of talking about these internals. So it's just not about diving deep inside SQL Server and just picking up a dozen internals about just about the architecture. That can be done. There's so much to talk about SQL Server, but the idea here was to pick up 5 specific things and spreading across dev environment, DBA stuff, and things that are meaningful, so that things that you learn and you can probably apply them with your day-to-day job. Okay. Now, few housekeeping announcements. Please use the Q&A panel for questions. A common question that keeps coming in is about the webinar recording. So all the webinars are recorded and they are available. They are available on sqlmaestros.com in the recorded webinar section. Here is the link in the chat window in case you wish to access. There are free webinars, there are paid webinars. The best way to get access to all the webinars, free or paid, including all premium videos, is to take up premium membership. If you go to sqlmaestros.com, you can explore all sorts of different options. And friends, for all of you, there are a few links that I have been posting in the chat window here. Those links are there once again. In case you are active on WhatsApp, you can join our WhatsApp community. It helps to have constant updates about our new content and the event announcements, etc. I'm also coming up with our popular annual performance tuning masterclass. It's going to go live in November. It's a 40-hour content program. Today, you're going to see some flavor of that as well. If you are a fan of live class, you may want to explore that. You get to attend live and you get access to the recordings for a lifetime. So that's the beauty of these classes. And of course, there are a lot of other things, the recordings and all in one bundle, etc. Okay, so let's get started with the content for today. Okay, before I do that, our customary stuff that we do each time in the chat window, just let me know which country are you from. I love to see the global participation each time. Okay, even the moment I was mentioning it, someone was ready. Thank you. There, so we have US, UK, Egypt, India, Philippines, Finland, US, Argentina. Wow, Argentina. Hi, they go Maradona. Yes, there. Okay, Bahrain, South Africa. Okay, Denmark. Wonderful. Kenya as well. Great. Thank you, friends. Thanks for joining. I hope today's content is worth your time. I mean, you're all in different time zones and you have been busy doing a lot of different stuff. So thanks for taking out time. Let's get started. Okay, so the first internal is about query memory. Now, I've chosen this title very carefully, SQL Server internals you may not know. I really want to be sure that there are at least a few internals that I'm talking about today that you are not aware of. My expectation is that when we finish this webinar today, today's content, you will be like, wow, I learned something new about SQL Server internals. I really want to have that feedback. If you did not learn anything new, if you knew everything that I'm going to talk about today and I'm going to show you, feel free to let me know. No hesitations at all. You can always tell me, Amit, you showed 5 things. I knew all of them. Absolutely perfect to have that kind of feedback so that I can do better next time. Okay, so let's get started with the first one, query memory. Okay, I'm going inside this folder. I know you're going to ask, what about the scripts, etc. They're all going to be available on sqlmaestros.com in the resources section. Okay. So first, I am going to open up in this demo one, I'm going to open a query here. Now look at this query here. It's a very simple made up query. Let's remove this while stuff and just focus on the select statement. Now, if you look at this query, it looks like a simple cross join that we are doing with the same table, right? But a cross join turns out to be very expensive. So if you see table one multiplied by table two, and then we are doing a multi-level sort. So we are ordering by A dot number, B dot number. Now, before I run this query, I will restart SQL Server. I want to show you the memory right now that we have on SQL Server. So let's right click here and restart. While this is restarting, I am going to take from the masterclass. Okay, this is a good opportunity for you to see what our masterclass content looks like. Module 1 to module 14, 40 hours of deep dive content. I'm going to pick up one script from here in SQL Server memory internals and troubleshooting. Let's go to memory overview, and I'm going to pick this up. I think the restart is done. I want to see how much memory right now I have with SQL Server. So let's go and run this simple dynamic management view query and extract the memory info. So SQL Server right now is consuming just about 500 MB. That is really the bare minimum the engine could really consume. It's because I've just restarted. So there are no workloads running. Now, what you are going to watch is when I run this query, you will see this query is going to consume a lot of memory. That's the internals we are going to focus on. Typically, when you write a simple select statement, the default, there's a setting in SQL Server instance properties which say default query, default memory per query, which is about an MB or so. That's just for the query execution, for the engine. But sometimes queries like these consume a lot of extra memory that goes unchecked. It will be like SQL Server instance has suddenly spiked up in its memory consumption and you are absolutely clueless as to what is going on. And this is what I want to demystify. So I'm going to also turn on the actual execution plan and now watch the fun. We are going to execute this query. It's running. We jump over to the memory overview. Earlier, this was 500 MB. Let's go and execute this now. Straight away, it is about a GB. Now you can see 1000 MB. Hope you have noticed that. From about 490, we go to 990. So about 500 MB is consumed. Let's go and execute this once more and see where we are. Okay, that's where we are. About 500 MB of memory was consumed with that single execution of the query. Let's go to the query itself. The query execution has completed. The surprising part here is that this doesn't seem to be a very expensive query. If you look at the output, we just kind of got about 10,000 records out here. Okay, fair enough. Let's jump over to the execution plan. Let's go and look at the query cost now. So I'm going to take the operator here, select, and let's go and look at the cost of the query. The cost of the query in terms of units is about 296. Even that's not expensive. So this is an inexpensive query eating a lot of memory. What is that memory? And why is SQL Server, why is this query requiring so much memory? And this information is available right here on the select tooltip. So let me just zoom in once more because I kind of hit that. Now, if you look at memory grant, this says that this query needs or was required 896 MB. Now, SQL Server engine had about 500 of MB even before the execution, which means when this query started its execution, it was able to consume some memory, which the engine had, and then it asked for extra memory or more memory. And SQL Server took that from the OS. That's the internal part of the SQL Server operating system. But this simple query execution required so much memory. This is the internals that you need to know, that query execution sometimes goes very expensive. Don't just be blinded by the cost that you see here. 300 units, 500 units. It could be much, much more expensive than the number. Look at the resource consumption. The resource consumption here is about 8 GB. Now, watch this. What if we make this query a little more expensive? I am just going to copy this here and paste it here and just put something like this, and okay, and let's go and make it c dot number descending. Okay, we are going to run this test once more. So I'm going to execute this now. SQL Server Engine is consuming about 990 MB. This is what you see. And now we will run this workload once more. I've turned on the execution plan. Let's go and execute this. This is probably going to take a lot of time. Now let's see the memory consumption. 1118, 1356 MB, 1815. Keep an eye on that first attribute. 1816, 1816. This is where we are. So from 990 MB, which is about a GB, we go all the way to 1800 MB, 1819. Are we going more? No, about a GB more, which means this query turned out to be much more expensive in terms of resource consumption. Okay. Now, if you were sitting next to me here, you would see the CPU fans burning, etc., because this is an expensive execution in terms of resource consumption. So what I'm going to do is I'm going to stop this and not really wait and show you what exactly was happening behind the scenes. So let's just get rid of this and only run this one, just to understand where was this memory coming from, and why did this query needed that much memory. So let's jump over to the execution plan, and all right, let's use the chat window now. Look at the execution plan, friends. Tell me, where should I start my investigation? In this execution plan, this is taking about a GB of memory. As you know, it's quite evident from the toolbar there, tooltip there. You can clearly see the numbers once again. What looks little unusual here? Where will you start your investigation? Okay, take a deep look. Let me know. Okay, there are some answers coming in. Brazil. Okay, no, that's the name of the country. Sorry. Sorting, select, spool, sort. Okay, sort. Couple of you are trying to highlight sort. Isn't it quite evident? Isn't it? If you look at this one, spooling at this point is not an issue because immediately my attention will go to sort, because sort is taking up almost 90, almost all of the cost of the execution plan is attributed towards sort. So if you take the cursor over sort here and look at, let's look at the cost here, estimated operator cost. So you could see 288. So out of the total cost that you see for the query, 97% goes to sort. Now, why is sort being so expensive here? Sort is being expensive because the cross join that you're doing between these two tables, it's quite expensive. And then that in-memory result set that you get from the cross join, you want to sort it. Now, SQL Server, when it has to do this sort, the simple sort algorithm requires a lot of memory. And you are only fetching 10,000 records here. If you make this 10,000 something like 100,000 and you run this once again, I'm not going to run this because it's going to take a lot of time, you will see the memory consumption increasing. So the catch here is in-memory sort with SQL Server Database Engine is always going to be very heavy on resource consumption, which is the memory utilization. This is also evident from the fact that if I sorry, where was that? If I do this once more and I run this, which means the more expensive version, I can actually check this while this is running. I can go to a DMV called sysdm exec query memory grants, and I can figure this out from here, the extra memory grant that the query needs. So let's go and stop this now, because the DMV, this is a real-time DMV that tells me that This query execution, okay, this is in KB. So you tell me the maths. Okay, so this is MB. This query actually required 1.3 GB of memory to do this expensive sort operation. Okay, so there are two aspects to query execution. One is the default memory that the query needs for its execution. The other is the extra memory grant. So this is what we are talking about, the internals in query execution, the extra memory grant. There are iterators in query execution that will ask for this extra memory so that they can complete their operation. Typical and classic examples are expensive in-memory sort. That's one. The second is hash operation. Then there could be parallel exchange operators. These are some classic examples of extra memory consumers. So when you see SQL Server memory shooting up, it could be one or more of these queries that are taking extra memory, and you got to track them. Though the easiest way to track them is via this DMV, which is a real-time DMV. You were able to get this output because when I ran this DMV, the query was running. Now that the query is not running, if I run this DMV, it's just going to give me an empty result set. So this is a real-time DMV, which means if you are doing constant baselining and benchmarking, you got to probably run this a little more frequently like a job, and get the output and insert it into your baseline tables or baseline database or whatever, so that you can go back and check into history as to what was the memory consumption like a few minutes ago or a few hours ago or a few days ago. Okay. Friends, this was the first one, query internals, right? First internals, which you may not know about query execution, the memory consumption, this extra memory grant that the query requires. Okay, how many of you learned something new? Just type yes, yes, yes. And if you had known this already, great. There is four more to come. Okay, cool. Looks like a lot of you. You see this file here, which says resource semaphore. Okay, so I'm not going to get into weight stats and weight types, but every concept and every topic is just so huge. And to complete this, fully, of course, that's why, and that's where the masterclass, etc., comes in. But I hope you have learned something new about query internals and execution. Let's move on to the next one. Let's close this. So we did the first one on query memory, query extra memory grant there. Next one, let's talk a bit about CPU affinity. Okay. Now, why did I use the CPU affinity here? Because there was a classic case in a recent consulting engagement where, and again, a very classic scenario where they were, it was a heavy box. The box had like about 96 logical processors, 96 logical processors, and about about 128 GB of physical memory. And there were two instances of SQL Server running. For whatever reason, they had this decision of not putting up another hardware, and they set up two instances of SQL Server on that same box. And what am I hinting at? We are talking about sharing resources between these two instances. So what is the server resource that you're sharing? You're sharing memory and you're sharing CPU. You might be sharing IO as well, but let's assume the IO is in the SAN. So yeah, that's a separate storage out there. But on the box on the server itself, you have CPU and memory. So there was a lot of discussion as to what's happening with CPU consumption and how both the instances are competing for resources. Both instances are being heavily used. One is for dev environment out there. It's not really dev. They had a different dev server. It was like something like pre-production. So before they actually deploy changes to the production, they're kind of doing some real production testing on that box, and they need a good hardware. So probably that is what was going on there. it wasn't a big nuisance there. You might think, okay, why would someone do a pre-production testing on production box? But they were just doing some specific things there in terms of query execution, heavy query reporting, etc. They wanted to test that, and they needed good hardware. So they were doing that. But then when they were doing that, it was competing for resources. This is where the CPU affinity thing came into picture. So what I will show you here is a thing that you should be aware of. Again, something to do with internals of SQL Server. And this is known, but I still thought of including this. Look at the CPU graph here right now. So we have 8 logical processors on my VM right now. Everything is very quiescent. Okay, nothing is running. So everything is very happy. Now I am going to stress SQL Server. Okay, so I have a batch file here, a workload. Let's go and stress SQL Server. And if you look at the graph now, there you go. You will see that all the 8 processors are being used almost equally, right? So you can see CPU is spiking at 99%. Look at the utilization there. It's 99% and more. And if you look at the graph, all are being used. Now I'll do something. I don't want SQL Server to use all the processes. This is my pre-production server. I really don't want it to hog all the processors, all the resources, CPU resources. I'm just testing a query and I'm okay with just one CPU. So what I can do is I can affinitize this instance with just one CPU, because this is only for the purpose of testing. Let's go back here. And now you will notice some change on the fly. I have not stopped the workload. This is happening real time on the fly. Okay, friends, what do you observe in the graph? Can you tell me? What observation do you have with the graph? Processor 1, 2, 3, 4, 5, 6, 7, 8. What do you see now? Yes, just look at the graph carefully. What has happened? Yes, you can only see this processor being used now. Earlier, all 8 were being used, but now only this is being used, and these are not being used, right? Okay, I'm going to take one more second and draw this finally. Okay, there you go. This is good. Sometimes these options, these settings come to rescue, I am not trying to tell that this might be a permanent solution, but given a scenario, this worked well for that other instance on that box, and whatever that management or technology decision they had, that okay, let's go and set up another instance and a few queries could be tested. But those heavy workloads, when they were testing expensive queries, they were like eating up all the CPUs, and you don't want these queries to eat up all CPU cycles. So that specific instance was affinitized only to one CPU. Worked well. What you could do now is the other instance. Okay, let me just stop the workload. Okay, CPU fans are burning, so I'm just going to stop this. Let's cross this. Yeah, now you will see everything dying down. You will see first CPU also now going off. So what you could do is, if you have eternized that first instance with CPU 1, the other instance could be affinitized with the remaining CPU. So I'm actually talking about 1 versus 95 CPUs, or whatever that configuration is. If you have a need that query which you're testing should be parallelized, then you can affinitize that instance with, let's say, 8 CPUs or 16 CPUs, and the other instance with the remaining ones. Okay, this is affinitization of CPU in SQL Server. If you want to watch the remainder part of the webinar and all the remaining demos, you can subscribe to the webinar on sqlmaestros.com and get lifetime access to the recorded webinar. All you have to do is just go to sqlmaestros.com, click on the recorded webinar section and get access to all the webinar recordings. There are many of them. Some of these webinars are free and some of them are very nominally priced. So the ones that you're interested in, you can subscribe to them and get lifetime access. Now, because there are so many webinars, subscribing to each webinar might be a bit cumbersome. So we have another option, which is SQL Maestro's membership. So the first link on SQL Maestro says join. If you click on that, it will bring you to SQL Maestro's membership. Things are very simple. There are two membership levels. The first level is free, where you get access to all the free webinars and all our tutorials and demos, more than 200, 300 demos and tutorials. All you have to do is just become a free member. You're paying nothing and you get access to all of them. So you don't have to go and subscribe to each webinar individually. Just become a free member and then explore the free video lobby. So if you go to the video lobby here, there is something called as free content where you get access to all of that. But then all of us are interested in advanced content, isn't it? And that is where premium membership comes into play. So the webinars that are paid, and there are many advanced tutorials and demos. If you want access to all of them, you can become a premium member and pay a nominal price, which is annual membership. Once you do that, you can explore the premium video lobby. If you go to the premium video lobby from here, or just go to the video lobby and click on premium content, you can see all the paid webinars and all the advanced tutorials and demos and get access to all of them with your annual membership. Anyway, choice is yours. There's a lot of content on SQLmaestros.com, and you can also explore the YouTube membership level as well. So you have free content on YouTube channel, and you can also join and become a member of SQL Maestros on YouTube, where you can pay a monthly fee, get access to all the paid webinars and advanced content. So in summary, you can go to SQLmaestros.com and become a member, or you can become a member on YouTube also. Becoming a member on SQLmaestros.com turns out to be a little cost effective with the annual membership in comparison to YouTube monthly membership. But anyway, choice is yours, whichever platform you wish to use. Happy SQL.